Before we talk about the lagging and leading DNA strands, I'd like to touch on another factor, topoisomerase. I already mentioned how helicase breaks the hydrogen bonds and separates the DNA strands. Topoisomerase acts like a rubber band, widening around the strands to prevent too much torsional strain from the sudden tension. Now that you hopefully understand how topoisomerase works, we are free to move on to the bulk of this video. The leading strand is way less complex than the lagging strand, so let's start with that first. DNA polymerase III is the enzyme that follows the RNA primers, placing down nucleotides as it goes. It follows the same direction as the leading strand, 3 to 5, so the primase only has to touch the leading strand once. DNA polymerase III does the rest for the leading strand and produces nucleotides away from the original RA primer. In this example, the polymerase III is moving to the right. This is why the current strand is called the leading strand. It leads ahead of the lagging strand in production. Yes, the lagging strand very much lags behind. Since the template for the strand runs from 5 to 3, DNA primase gets used many times. To combat this, another type of DNA polymerase latches onto the primers and turns them into nucleotides. This polymerase is called DNA polymerase I. Think of it as a Pac-Man that excretes monomers as it moves forward. Even after polymerase I leaves, there is still some space between nucleotides. This is where DNA ligase comes in. This enzyme attaches to the brakes and patches them up, preventing the new strand from falling apart. And there we go. This has been an overview of how DNA gets replicated. I hope you enjoyed, and please tell me how I can improve for the next videos to come.